Hello everyone. So in the part 1 we have seen the casted the beam like for testing of flexural strength of this Rainforce beam. After 28 days of curing, the beam has been kept in open place for dry for 3 hours. After that we are going to test the after it is painted with cement color to know the crack patterns on the beam. So this is the how we are lifting the beam of 1 meter size with the help of chains. So that is going to be placed upon the 2 supports. So you can see here on 2 supports we are going to place at exact center of the 2 supports. So the test was carried out in the structural loading frame. Hydraulic loading system was adapted for loading equipment. The maximum thrust load is going to be applied on this beam. The stiffness of the supporting structure of the testing beam must be large enough to reduce the measurement error. In order to avoid the local failure of concrete, 2 20 mm width armor plates are embedded into the bottom of the RC beam to support beam and loading steel beam respectively. So here the beam is placed on the 2 supports at the mid span. So you can see here these are the 2 supports on which 1 meter beam has been placed. So after that we are going to mark the beam at about 1/3 from the supports, 1/3 with the help of supports. So the test was carried on a loading frame to our loading frame. The maximum loading rate was up to 10 mm per second. A high speed data acquisition system was needed to avoid the loss of test data. The dynamic data acquisition system is produced using technology to know the electric signals, and the maximum acquisition frequency should achieve 20 kilohertz. In this experiment, the effect of loading rates on the dynamic behavior of the pure bending segment was studied. You can see here. So the effect of loading rates in the dynamic behavior of the flexural beam. The failure configurations of this RC beam at different loading rates are going to be recognized. The failure configurations were the same as at different loadings. So you can see here the gauge is going to be fitted on the top of the beam for the application of load. So the different loading rates and the vertical cracks which are going to be seen on the bottom of the beam were caused by tensile failed concrete. By careful observation and comparison, the width of the crack decreased with increasing loading rates and they distributed more uniform. So you can see here the gauge has been fixed on the top of the flexural beam to calculate the influence of loading rate on the long loading displacements. So you can see here the gauge length is going to be fixed. After that the deflectometer is going to be placed at the bottom of the beam to measure the deflection. So there is a probing ring will be there. It will show the deflection. The width of the crack decreased with the increasing loading rates and they distributed more uniform. The reason may be that the rapid loading rate delayed the propagation of internal micro cracks and enlarged the crack field, which caused the developments of the external cracks. So more visible cracks appeared and the width of the cracks decreases with increasing loading rates. So you can see here the load is going to be applied with the help of gauge meter on the flexural beam to calculate the flexural strength of the beam. So this is the loading frame control panel. It will show the types of curves, that is at different loading conditions at the different supported on two supports, it will show the bending profile of the flexural beam. So the mid-span loading displacement curves. So the main objective is to determine the flexural strength of concrete beam, which comes into play when a road slab with inadequate subgrade support is subjected to wheel loads and there are volume changes due to temperature or shrinking. So here methods of tests for strength of the concrete beams. So flexural testing machine. The bed of the testing machine shall be provided with steel rollers 30 mm in diameter on which specimen is to be supported, and these rollers shall be so mounted that the distance from center to center is 60 cm for 15 cm specimens. The load shall be applied through two similar rollers mounted at the third points of the supporting span, spaced at 20 or center to center. The load shall be divided equally between the two loading rollers, and all rollers shall be mounted in such a manner that the load is applied axially and without subjecting the specimen to any torsional stresses or restraints. So here we need to clean the bearing surface of the supporting and loading loaders, and the specimen, the load shall be applied at a rate of loading 400 kg per meter for the specimens, at the rate of 180 kg per meter for the 10 centimeter specimens. So after that we are going to calculate the flexural strength or modulus of rupture of the given beam with the help of formula, that is F suffix B. So we need to take the safety precautions. So we need to use hand gloves while safety shoes at the time of test. After test, switch off the machine. Keep all the exposed metal parts greased. Keep the guide rods firmly fixed to the base plate, top plate. Equipment should be cleaned thoroughly before testing and after testing. So this is how we are going to note down the core pattern of the failure of the flexural beam, pure bending flexural beam. So you can see here in this, we are going to see the graph, how it is, the curve has been indicated in the second graph, that is flexural crack patterns, that is profile of the beam, how after application of load. So usually the precautions must be taken, and the flexural strength of test concrete is done according to IS 516/1959. So this is how the pattern is going to be changed after attaining maximum load. So yield load we have seen and after that ultimate maximum load we need to calculate for the complete failure of the beam. So you can see here yield point, and it is slowly decreasing because it is completely failed. So you can see here the graph, you can see here in the second graph, at a certain point it is reached and after that it has decreased. The capacity of the beam is no more to withstand the load which is supported on two supports. So this is how we are going to test the flexural strength of the beam. So in the next part we are going to, so in the part 3 we are going to show the calculation part, that is to calculate the flexural. So you can see here the crack patterns on the left side at the nearer to the support. It is slowly failing, the beam is failing after the application of load. So you can see here. So this is, you can see here, right side also the beam is cracked at the maximum crack that has been observed at the supports. Next we need to remove the plates, and we should note down in the system what is the ultimate load, yield load. So this is the loading frame. The loading frame control panel will give the all the results. So in the part 2 we can discuss the. So this is the part 2 video showing the flexural strength, how to calculate, how to test on loading frame. So in the part 3 we will discuss the calculation part, detailed calculation part, how to calculate the flexural strength of this beam.